Hello, everyone. Welcome back to my messy whiteboard. Today, I'm going to chat with you about some of the essentials of networking, and particularly so the mechanism through which anything that's happening on Web3 takes place, is instantiated over networks. And we're going to start with, one of us here sitting at home. We start off by deciding to initiate a transaction. So we decide to initiate a transaction, and it first goes over the first hop of the trip of this transaction. Maybe it's Wi-Fi, and here you are sort of struggling to get Wi-Fi with whoever else is in your household, or maybe also your neighbor's microwave. Then it gets to, a first, what's called an access point in your neighborhood, maybe inside your apartment building. Then it's going to go through some fiber, which is, of course, shared with all kinds of other people. And then it goes from more and more of these different access points. And throughout, it's going to go through something which we represent like this as electrical engineers, which this kind of X-looking thing is actually a switch. So it's going to go through switches and routers. A switch is the physical machine that actually connects inputs to outputs, and the routing is what decides what action that machine takes. So think of the routing as actually being the software part, and the switch as being the hardware part. Okay, so eventually it gets through here, and it's going to get, of course, to some block builder. And the way it's going to happen here, that it gets through a block builder, is that it's going to go through a variety of these different switches, all over the world. And there's going to be all kinds of fancy routing. So this is also going to be coming from all kinds of other places. And your block builder is going to go ahead and build a block according to these different transactions. Now, this has to get on chain, and basically it will have to go through a proposer. And the proposer, maybe the block builder managed to get a proposer connection that's pretty good, but generally, again, here you will still have all of these switches. It's not like there's somebody with a roll of fiber connecting everybody to everybody else. And then this proposer is going to have to talk to a bunch of validators and get enough of these validators to agree and validate whatever the block is. Okay, so let's look at this proposer. There isn't a dedicated fiber going from a proposer to each and every validator. Let's think about it. If you did have this kind of direct connection, suppose that I have 100 validators, or maybe let's just say 1,000 validators. That's 10 to the power of 3. That's basically not more than, say, Ethereum has. Or if you think of something like Rotor in Solana, you'll have to be talking to 200 of them. So let's even just bring it down, say it's 100, which is 10 to the power of 2. Each of these nodes, right, because the proposer takes turns being proposer, sometimes it's just a validator, sometimes it's a proposer. If each of these had to have a dedicated connection to the other, with something like Ethereum, even if you think that there's only 1,000, which of course is not true, there's a lot more than that, you would need roughly the square of that, 10 to the 6. You would need basically 1 million separate dedicated lines going across the world. Not happening. Think even of something like Solana, with even if you have to contact 100 of them, you would need now 10,000 different connections, different pieces of fiber going across the world in all kinds of awkward spots to try to connect everybody directly to everybody. So that's basically not what's ever happening. Okay, you're always going through a network, and inside this network, there's a lot of different switches where those switches are basically doing the routing, or again, the routing, if you will, is the software part of operating the switch. So the idea that you can have, dedicated links or point-to-point links is simply not feasible. It just doesn't scale, right? You can't do this many dedicated lines. And then what would happen is if a new node came in, all of a sudden then you would have to run 1,000 new lines to connect everybody to everybody else, right? You would never, ever add a new validator. So it's really important when we talk about bandwidth to realize that even if you may have some portions that are fiber that's dedicated to something, those portions are never actually point-to-point portions. They're just portions inside your network, which is then connected to a variety of different switches, and that the reality is always that you are in what we call a switch network. So this switch network is basically the reality of any system. You can, of course, speed up some links here and there by putting in some dedicated fiber. That's great. But that's not really changing the underlying operation of a network. And it can't. It can't, just from the math of it. So we'll continue to talk more about this, and also think even in a very simple system, how the bandwidth here, if you're doing, for instance, in Solana, something like a star system, has to be shared. And what are the effects, what are the consequences of that sharing? So just remember, there is no such thing as a dedicated link.